Okay. All right, in class, we were talking about a problem that asked you to prove that the sum of a number and its reciprocal was greater than, or at least 2. So let's figure out how we started doing this, right? So we're going to say, okay, let's let x equal some number. Okay? So then the reciprocal, remember, some of you figured out was this, is the reciprocal of that number. Okay? So what we wanted to do then is to prove that the sum of x and its reciprocal is at least 2. All right? And we were going to do this a couple of different ways. The first way was to use the calculus methods that we had started doing. All right? So, okay, we're going to let our function equal this guy here, the sum of a number and its reciprocal. All right? So then we wanted to show, right, that f has a minimum at 2. Okay, and there's our buzzword over there, all right? And you guys remembered, oh, this means set the derivative equal to 0, all right? We also want to make a little mental note that we talked about before, right? F prime is also undefined at 0, right? But 0 is not in the domain, so we don't need to worry about this. It's still going to be counted as one of our critical values when we make our sign chart over here, but it's always good to make a little mental note about these things. We want to kind of rule this information out. All right, so really what that does is once that this is all ruled out over here, we can just focus on energy and solving this equation. So first, we find our derivative, right? Derivative of x is 1. If you don't remember how to do this part from class, that's okay, but we've done this many times, so we're just going to get right to work. And if you want to go back and find the derivative of 1 over x, you can do that. And so now we want to set this thing, right, equal to 0, and that will help us solve our critical points. So simple enough, we'll add this to the other side, multiply by the x squared, so we get 1 equals x squared. That means that x squared is equal to 1, which means that x is equal to plus or minus 1. Okay, so as we said, 0 is not in the domain, but we're still going to count it as a critical value. So we now make our sign chart over here. All right, let's do that over here. All right, and so let's make our sign chart. We have this. We're going to make 0 on this side. We've got 1 over here, and we've got -1 over here. All right. Now, one last thing. In order for this to be possible, right, both of these numbers have to be positive, okay? So what we're going to do is just impose this extra little condition in for right now, all right? So we can sort of get rid of all of this. We could have technically said that at the outset, but if we had, we would have thrown it out over here anyway. So I decided let's just solve the equation, then we'll get our solutions, and then we can say, well, hold on a second, let's make sense of our solutions over here. And if you go back to this original equation, and if we're trying to work this one out, right, then it makes sense to say, hey, let's ignore this -1 over here, and let's just focus on the positive portion of it. All right, so now we'll get some test values in here. We can plug in 1/2, and why not plug in, we could plug in 2 to the derivative, right? So we'll plug them in to our derivative function over here. All right, right into this we get 1 minus 1/2 squared, which is 1 minus the reciprocal of 1/2 squared. And this is a 4, right? So this becomes 1 minus 4, which is negative. So we're getting, our function is decreasing there. And then we're running out a little bit out of room over here, so why don't we continue over here? We'll plug in 2 to our derivative, and this will give us 1 minus 1 over 2 squared, which is 3/4, and that is indeed positive. And so, bingo, exactly what we want. We see that this is a minimum. Oops. And you know what? I made a little mistake over here. This is wrong. I got to fix that later. All right, x equals 1. All right, so we see that, right? So we see right, x equals 1 is a minimum, right, of f of x, and f of 1 equals, let's work that out over here, I'm sorry. F of 1 equals 1 plus 1 over 1, which is indeed 2. All right. And so there we go. We have now shown, all right, that f of x has a minimum. I should have put minimum value. Oops, this is a little bit messed up over here, so I have to clean that up. We have shown this. There we go. So we've now shown that f of x is indeed greater than or equal to 2, and there's our calculus method. So there are two other ways we can do this. One of them is using the second derivative, the concavity test, and then the third one is using plain old algebra. But at least for right now, we finished that part off, so we're good to go.